Hello, hello. So, lecture 16. We have very similar student exercise like yesterday, but number one was about recursive function. And I was starting to do it when I accidentally saw that they just gave us the answer here at the bottom. So that kind of ruined it for me. So I'm not going to spend any time on that because we already have that solution. So I'm just going to quickly go over this class definition. We have to create a class called car, and it has three properties, and it should have three methods. So we can accelerate, we can brake, and we can honk the horn. So this is very similar like yesterday, so I will just go pretty fast through this time. But there's one small difference, and that is if the speed isn't specified, then it should automatically be set to 0. Now we can change our parameters to be optional, not required as before. So I'm going to show you how we can do that. So we just start here by creating a class called car. And we need our private variables just like before. So double underscore model. And I'm going to say this is just an empty string. Then we have our year. And I'm going to have it an integer, 0. And speed will be also 0. And then we need our initializer. So that's double underscore init. And we're going to pass in the self, and we're going to pass in all those three properties. So it's going to be model, year, and speed. And whatever is going to be sent in as the first argument is going to be passed into here. Just close my messenger. So self dot underscore underscore model equals model. And we're going to do this again. Self dot underscore underscore year equals year. And self underscore underscore speed equals speed. Okay. So now we can just try to test this class by creating one instance of it. So I'm going to call it C1. So it's this car1 equals a new car. And I'm going to pass it in a string model Toyota. The year 2020, speed, let's just say 50. And I can press hold shift down and press enter. And that will actually execute this cell. So I don't always have to go here in the top left corner and press this play button. So no errors. And I'm going to print out c1.speed. Well, I cannot actually do it because it's hidden. Okay. I'm going to make this a public variable for just a short amount of time because I want to show you one thing. So I'm going to draw this back. So self speed equals speed. Build it again, no errors. So c1.speed, I'm going to print that. And shouldn't be any surprises here. It's going to show us 50 after I run it. Now the assignment says that if speed isn't specified, then it should automatically be set to 0. So what happens if I remove this here and build the program? It says, hey, there's an error. I was expecting 3 arguments, but 1 is missing. So we gave them 2. They're expecting 3, so 1 required positional argument speed is missing. So to get around this, we can change this here to an optional parameter. But for it to be optional, we have to give it some default value. So if nothing comes in, it has to be set to some default. And I'm going to say here the default is equals to 0. And I can do this. So if I run the program now, we can see I built one object of this car class stored as C1. I didn't give it any speed. So when I print out the speed, it's going to be 0. This 0 has nothing to do with it. But it's good for us to give it any data type, so we know that when we are working with this variable later on, it is an integer. You can see there, it's a type of integer. If I do nothing, it will still work or not. No, not defined. But okay, let's change this here to 12. And I can run this, and we can see here c1.speed equals 12. Didn't give it any speed, so it's going to default to this. But if I give it a speed here of 40 and run the program, it's going to take this over the default. So that's a nice thing to know. But okay, so if we just continue, the default should be 0 if we don't pass it in any arguments. But I'm going to pass in 10. I think that's fine. Okay. And now when we have our base of everything, we need to create our boilerplate code, which are the properties with the getters and setters. So let's just do that, and let's just start with the model. So I'm going to create two methods. It's going to be get model and set model. So define get model self. It's going to return self dot underscore underscore model. That's it. And then we need the setter. So define set model. Pass in the self, and whatever value we're going to pass in, we're going to store it in self dot underscore model. And pass in the value. I'll pass it through here, like so. And then we want a property to be able to access easily, and that property will either execute the getter or the setter. We should, however, be able to say c1 dot set model, because this is just like any other function, and I can actually set the speed here by passing in 40. And it doesn't make sense to print it because this doesn't have any return. So c1 set model, and this doesn't make sense. It's not speed that I'm working with. So let's say BMW, and I can print c1.module now. Well, no, actually I cannot because I don't have any public variable name module, but I can print c1.get module. And if I run this, you can see that the car is now a BMW. But if we don't want to have to use the function every time, we can create this property, and I'm going to call it model. And it is a property. And whenever we want to get something out of it, we're going to execute the get model function. So get module is the first parameter. And whenever we want to assign value, we're going to pass in the function to set the module. So set module would be the second parameter. And now I don't have to call this. I can just say c1.model equals BMW. And then print c1, c1.model. So here I'm using the setter because I'm assigning value. Here I'm calling the getter because I'm retrieving the value. Nothing new here. So this works. So I'm just going to do the same for, change this back here to private variable. I'm going to do the same for year and speed. Okay, so we have written out all of the spoiler code. There is a plugin. I did a research on it and I was going to test it before this recording, but I forgot about it. But we can add some extension to this, which actually just does this for us. Because this is a lot of time and effort on our part just to create some getters and setters and modules for something that, I mean, basically all that we did here was we created 3 properties and an initializer. And this is just all code for that. And we can reduce that with a simple code snippets. And I will have to take a look at that if we're going to use more of classes in the future, because this is just time wasted, in my opinion. But okay, we got all of this here. The next thing that we have to do is create an acceleration method, which should add 5 to the speed data attribute each time it's called. So really no difference in the method like getter or setters. We're just going to create a method called accelerate. And whenever we call it, we're just going to grab whatever is in speed. So self._speed. And we're just going to add 5 to it. Plus equals. That's it. And then we have the break. It's going to do the same, but we have to do some check if we're already below or at 0. So break. Oh, I typed it out incorrectly. So break like that. Okay. Accidentally pressed Shift Enter to run the code, so no worries there. So we're going to say here, whenever we break, we're going to take the speed. We're going to take the speed and we're going to lower it by 5. Minus equals 5, like so. But we have to make sure that if the speed is already at 0, that we're not going to take it down to minus 5. So we're going to do a small check here before we do this. And we're going to ask ourselves if the speed, so self.speed, if it's less than 5, so it means 4, 3, 2, 1, or 0, and yeah, shouldn't be able to go less than 0, but technically we could create the speed here with a negative value. We haven't done anything about that, but I'm not going to waste time on that. So if the speed is less than 5, then we're going to set the speed to 0. Equals 0. Otherwise, else, we're going to reduce it by 5. And if I run the code, no errors. So that works. So let's just do a test at the end. I'm quite confident that everything is okay here. So honk horn is the last method that we have to do. And this method should just print out Toyota or BMW goes beep beep. So define honk horn. We're going to print. And I'm going to use an F string. And I'm going to say self. Well, I'm going to do the curly here first. Self model. And why am I not seeing the self? Okay, it wasn't just helping me out here. Okay, self model goes beep, beep. Something like this. Run the code, no errors. So yeah, I think that's it. We can just test out the accelerate and brake functionality. So if I create a car here, Toyota module 2020 goes at 10, speed set to 10. I can say here C1 accelerate. And now if I print the C1 speed, and I did something wrong. Self.year, how did I do this? Okay. We're going to say here get speed, so return the speed value. Okay. So just a small entry error over there. So we create a car, speed is 10, we accelerate and print out, and it's 15. So if we brake, C1.brake, call the brake function, and print it out again, then we should go back to 10. If we break twice, then we're down to 5. If I break 3 times, we're down to 0. And if I break again, then we're still at 0. That also means that if I create the car here for the first time with the speed set to 4, we accelerate, so I'm going to remove that. So I'm going to print the speed, break, print the speed. So we start at 4, and then we just go down to 0. So this works. So when we have stopped the car, we want to honk the horn. So I say C1, honk horn, and Toyota goes beep beep. Unless if I change the name to BMW, then BMW goes beep beep. I think I've tested all functions so far. Yes. So this was a power run for today's assignment. Hope this helps.